You have a droplet, water droplet, and then this light comes, sunlight comes from somewhere, and then it refracts and partially reflects, and then it falls on the other surface, other side of this drop, and here again you have some kind of transmission and some kind of reflection. Part of it is reflected and part of it goes, and then here also part is reflected and the part is, it comes out, and it is this which you see. It is this which you see. Rest are all not useful for us. So that is how the rainbows form. The colors separate because at this refraction, this refraction, here is reflection. So at this refraction and at this refractions, colors separate because the refractive indices are different for different colors. So all those textbook stuff is there. Now, one extra information which is generally not in the textbook is that depending on where on the drop, depending on where at the drop this sunlight is falling, this direction from which you receive the light will be different. Because if it falls here, then everything will just go away. Normal and go away. Nothing will reach. But if it falls somewhere here, then there will be some refraction, and then at some other angle it will come. So the angle at which it comes depends on where on the drop the sunlight is falling. And it so happens that if the angle between this transmitted light and the incident light, if this angle is 40 to 42 degrees, then the light which comes out is most intense, because see, light is also getting lost here. Light is also getting lost here. There is a partial reflection here and partial transmission here, and here also partial reflection. So the intensity also depends on the intensity, how much of light is lost and how much of light has come out of this drop from this side. That intensity also depends on where it falls, where this light falls. The intensity corresponding to this will be different. And this intensity is maximum in the range of 40 to 42 degrees. 42 degrees for red and 40 degrees for violet, and remaining in between. And that is what we see, because if the intensity is too low, we don't see it. Okay, so keep this in mind. Okay, so now let me draw this diagram again and only showing the relevant lines. So this is our drop, and light is coming from left. Say it comes from here, and then this is the center. So it bends towards the center, and then reflects, and then again it transmits like this. This is normal, it goes away from the normal, and here I see it. And this angle between this, and I'm drawing parallel line here. Suppose this is horizontal. So from horizontal, this angle, same as the angle between this and this, because this is parallel to this. So this should be 42 degrees, 40 to 42 degrees. Different for different colors. Okay. So if I look at, say, not 42 degrees, say 30 degrees, 36 degrees, 35 degrees, I won't see color splitting. If I go 45 degrees, 47 degrees, if my eye is oriented this way, no colors. But is it the only drop at 42 degrees? No. there are many more drops at 42 degrees. Okay, so let me draw one of them which I can on the board. Just reflect it here, just reflect this whole thing here, and suppose this is the at 42-degree line, and then my drop is like this. Just reflect this. Light enters somewhere here, just reflecting it, and then there is a refraction, so it goes like this. Then there is a reflection, and it comes here, and then it once again goes away from the normal, and therefore it reaches my eye. Okay. Perfectly perfect. Same geometry. Just reflect it here and you see the same geometry. This drop also sends you a light. So this drop, yes, red, green, blue, everything. This drop, yes. So you can lift your eye this way. You can lift your eye this way, 42 degrees. But these are not the only two possibilities. This is 2 because I am using the surface of the board and it is not 3-dimension. If you go in 3-dimension, you can have 42 degrees in this direction, in this direction, in this direction, in this is 42 degrees, this is 42 degrees, this is 42 degrees. All these drops which are here, they are at 42 degrees. Let me show you using a cone. Look at this. Suppose this is my eye, and this is that horizontal line. The axis of this cone is horizontal line. So and this semi-vertical angle is 42 degrees. So draw any line on this cone. This one, yes, from that central axis, 42 degrees. This one, yes. This one, yes. This one, yes. This one, yes. Okay. So any line on this cone, all these lines are at 42 degree from that same horizontal. So if I have a drop here, 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 here, all these drops are at 42 degrees from my side. And therefore all these drops will send me that vibgyor, and all these drops are not on a circle but in that direction. Okay, the drop can be here, drop can be here, same, no problem. So the drops are not on the circle, but what I will see, this one, I will see just 1 point. This one, just 1 point. So all these things taken together will give me a circular view, and that is why the rainbows are circular. Since we are not able to see the full circle because we are generally on the ground, and then only part of that circle above the ground that we are able to see, and that is why it is always a circular arc.